each pair of problems here are very similar. So this is more about getting you to go through the process than it is about getting you to independently do a word problem, because the we do will be an example that you can pretty much just follow through to do the you do's. All right. So we're given the length and width of a rectangle, right, in each of the first two problems, and we're asked to find the given the perimeter, what length and width give us the maximum area. So we're thinking about a rectangle. Right. We're given a perimeter of 80 meters. And our perimeter is the sum of the sides, so 2L plus 2W. Then we're asked to maximize our area, right? And area of a rectangle is length times width. So we have our secondary equation, our constraint, right? We can only use 80 meters for our perimeter. And our primary equation, the one we're trying to maximize, or minimize, in this case maximize, which is the area of a rectangle. So we have to solve the secondary equation for a variable and substitute it into our primary equation. So if I go about doing that, I'll have 2L equals 80 minus 2W. Divide everything by 2. We've got L equals 40 minus W. We have to substitute that into our primary equation. So I've got 40 minus W times W, or 40W minus W squared. Once we've got one variable in our primary equation, we have to think, okay, what values are plausible, all right? Well, for my width, it needs to be positive, right? So we're doing our domain here. Needs to be positive. And then if our length was almost 0, our width would be nearly 40. All right. The reason that is because we've got 80 to go around the total. So our widths, we have to have 2 of them. So if length was virtually 0, our width would have to be just under 40 because we have 2 of those sides. All right, so we go ahead and do our derivative here. And then we have to solve that derivative for W. So set it equal to 0 and solve for W. We've 2W equals 40. W equals 20. So I've got 20 feet for my width. My length is 40 minus W. So in this case, 40 minus 20. So I've got a length of 20 feet. All right, so first we identified the quantities we know, then we substituted in, got a single variable in our primary equation. We thought about what values are plausible, and then we found those values by setting our derivative equal to 0. All right, let's consider now a problem where we are given, we're trying to find the length and width of a rectangle that give us the maximum, that have the given, a rectangle, I'm going to start over. Find the length and width of a rectangle that has the given area and a minimum of its perimeter. So we've got area of 32 square feet. And our equation for area is the same, right? Length times width. So I'll draw us another rectangle. And our perimeter is unknown, but we still know the equation for it. So in this case, we know our constraint is 32 for our area. So that's going to be our secondary equation. What we're trying to minimize here is our perimeter. So that's going to be our primary. So we solve our secondary for a variable. And when we do that, we'll have L equals 32 over W, or 32W to the negative 1. Substitute that in. I've got 64 w to the negative first plus 2w is equal to our perimeter. We're trying to figure out what our feasible domain is for that. So if our length was 0 and we know our area is 32, so if our length was really close to 0, then our width would have to be less than 32. All right. So let's go ahead and find our derivative. And then we have to solve this guy for when it equals 0. Multiply both sides by w squared. And we've got 64 equals 2w squared divided by 2. W squared equals 32. Do the square root. Remember, it's plus or minus, but we're talking about a width here, so we only care about the positive version. So we've got 32 square root. All right, and that's the same as saying 16 times 2. So I'm just going to reduce the radical, or 4 root 2. I believe our quantity was feet. Yeah. So our width is 4 root 2 feet, and our length is 32 divided by w, so 4 root 2. Right. When we have 32 divided by 4, that's going to be 8 over root 2, and we can rationalize that, multiply by root 2 over 2. Got 8 root 2 divided by 2, or 4 root 2 feet. And there you have it. So go ahead and try those you do's.